energy is the key. We have to have abundant, affordable energy in order to solve the global poverty problem. You know, population is still shooting up, and we can't really afford, in order to solve most of these problems, the population problem needs to come under control. Well, it has come under control in half the world. The wealthy half of the world, the fertility rate is now at or below replenishment levels. But it's the other half. It's the poor half of the world where population is still shooting up. And in order to solve that problem, we need abundant, affordable energy. In the case of the climate problem, is it okay if I'd sort of like to know what I'm showing. And
Sure.
I don't like to have my back to,
This is great.
to the audience. These are new charts, so it's a little bit unfamiliar to me. We have a crisis. We have a global emergency. And yet, by and large, the public is unaware of that. And the reason that can be is because of the inertia of the climate system. When we add carbon dioxide to the atmosphere, methane, it increases the opacity at infrared wavelengths, the wavelengths where heat radiation is emitted to space. And so if we block that radiation, we're causing a planetary energy imbalance. There's less energy going out than there is coming in. And it takes the system a long time to respond to that because of this great inertia of the ocean. So we've only realized about half of the warming due to the gases that are already there. And we're already beginning to see climate effects that we don't like. But there's more in the pipeline. And so the bottom line is that we're going to have to rapidly reduce these forcings that are causing the climate change. That means principally fossil fuels, carbon dioxide emissions. And it turns out that if we would address this problem in a sensible way, which is still possible, it actually has many benefits. It does not, and I don't agree with the claim that was made yesterday that, it's going to cost a small amount, it's going to cost 1 or 2%. You may have heard that global warming has stopped, or that's actually, if you look at global temperatures, the last 15 years or so, there's not an apparent continued increase. Although if you average over 11-year running mean, 132 months, you see that temperatures are still going up. And in fact, we know they're going to keep going up. How do we know that? Here's the decade by decade temperature changes, and each decade has been warmer than the preceding one for the last several decades. The current decades, the first 3 years of it, are the same temperature as the previous decade. But we know that this decade, by the end, is going to be warmer than the previous one. The reason that we know that is the planet is out of energy balance for the reason I already mentioned. There's more energy coming in than going out. Therefore, the planet's going to keep getting warmer. And we can measure this energy imbalance now quite accurately because most of that energy goes into the ocean, most of the excess energy, because the heat capacity of the atmosphere, which is very thin, is very small. But the ocean is 4 kilometers deep. It takes a long time for it to warm up, and that's what's happening now. There's energy going into the ocean, which is going to have an impact I will mention in a minute. But we can now measure that because of these Argo floats that are distributed around the world's ocean now, and they dive down to 2-kilometer depth and measure temperature, and then come back to the surface and radio the data to a satellite. And what we find is that the ocean heat content is continuing to go up. And the data up to this year shows that's just continuing as we know it must. And that amount of energy is only 0.6 of a watt per meter squared, which doesn't sound like much, but it's the total for the planet is equivalent to 400,000 Hiroshima atomic bombs per day, every day of the year. It's a lot of energy that's being poured into the ocean, and that energy is going to have consequences. So I'll talk a little bit about three different things. The first two are irreversible. If we drive a significant fraction of the species on the planet to extinction, whatever fraction we do, that's a permanent change. You can't reverse that. And likewise, sea level rise from ice sheet disintegration, it takes tens of thousands of years to build up Greenland and Antarctic ice sheets. So if we let those disintegrate, it's a permanent change. We lose all the coastal cities forever. So I'll say a little bit about extinctions. The climate change so far is moderate. Global warming is less than 1 degree Celsius so far compared to pre-industrial conditions. But it's already enough in combination with all the other stresses that we're putting on different species to have an impact. In the case of the climate, the climate zones are shifting at a rate of actually a few kilometers per year, shifting poleward because of global warming. And so species can try to migrate to stay within the climate zone that they can live in, but there's a limit. The rate at which we're making changes is an order of magnitude faster than any that have occurred, any warmings that we know about in the Earth's history that have occurred before. So and also humans are just in the way as species try to move. So I like to use this insect as an example of the combination of climate change and other stresses. The monarch butterfly is a remarkable insect which migrates all the way from Canada to Mexico and in an annual cycle where it hibernates in a small mountainous area in central Mexico. And I thought this was a nice species to introduce my grandchildren to nature. I didn't realize that they may be witnessing the extinction of a species. But a few decades ago, my wife and I could sometimes see a dozen or more monarchs at the same time. Now, if we see one at a time, it's become fairly infrequent. But this one butterfly that was in our backyard in 2011, I could identify because her wing was broken. And she hung around our yard for a few weeks. She was the only monarch at that time. And she produced about 25 or 30 of these larvae caterpillars. And they went off, crawled off in our privet bushes, and here were two of them coming out of their chrysalises and becoming these butterflies. One of them was a male and one was female. You can identify with these much broader, these vein-like things are much broader on the female than on the male. We wondered how many of these butterflies would make it to Mexico to hibernate for the winter, because they had to go through Texas, and this was a huge drought in Oklahoma and Texas that year. Well, I wrote an article about that butterfly, and a Mexican scientist sent me a photo of some of the fir trees where the butterflies hibernated, and that's his grandson looking up at the butterflies. And what he saw was not only the monarchs flying around the fir trees, landing on them, but the fir trees are under stress because of continued drought in Mexico as these climate zones are shifting. So that scientist is trying to persuade the Mexican government to plant these trees higher up the mountain where the conditions will continue to be appropriate for that species of tree. But because, by the way, the stress that humans are applying to the monarch is Roundup, the defoliant, the thing that farmers use to kill weeds. They kill milkweeds, and milkweeds are the only thing that a monarch larva can eat. So that's the main cause for the decline in the number. But I think also, I'm afraid that we've reached a point where that monarch, the eastern monarch that goes from Mexico to Canada and back, may be on the way to extinction because there just aren't enough of them for a chance encounters between the male and female to reproduce. And each year, in the last 3 years, the number has declined markedly. It's now about 5% of what it was a few decades ago. But I still think we could save it if we could just figure out this Roundup problem. Coral reefs are the rainforest of the ocean. There are about 1 million species associated with coral reefs, and the coral reefs are under stress for several different reasons. But climate is part of it. The warming of the ocean causes, when you get too warm a peak in the ocean temperature, it will cause the coral to expel their symbiotic algae and die. And also the ocean acidification is a problem for all species that have skeletons or exoskeletons that are made of carbonates. So we're losing about 1% or so of the coral reefs per year. There's a danger we could cause a lot of ocean extinctions in that way. Okay. Sea level. The basic problem in sea level is the melting of the ice shelves, the tongues of ice that go out into the ocean. As the ocean gets warmer, it melts these ice shelves, and that then allows the ice sheets on the land to discharge ice to the ocean more rapidly. The land-based ice sheet on Greenland is beginning to melt because of the surface warming that contributes to it. Temperature fluctuates from one year to another, but in general it's getting warmer, and the area on Greenland with summer melt, the red area, is increasing over time. And that meltwater will burrow a hole in the ice sheet and go to the base of the ice sheet, lubricate it, and speed up the discharge of icebergs to the ocean. And so the ice sheet is now losing mass, and we can measure that from the gravity satellite, which measures the gravitational field accurate so precisely that we can see how the mass of the ice sheet is changing. It gets heavier in the winter as snowfall piles up. It loses mass in the melting season, and overall it's losing mass at an increasing rate. Now a few hundred cubic kilometers per year, which is, the sea level is going up at 3.2 millimeters a year, so that's a little more than a foot per century. So it's still a modest rate, although we can see the effect in Florida and places where it's beginning to be noticeable, but it's still small compared to what is potential if we fall off that cliff and really get rapid disintegration. But what's really the most important thing is not this surface melting on the ice sheets. It's this melting of the tongues of ice that go into the ocean. And now what we just realized is that the melting of the the ice shelves underwater around Antarctica is at a rate which is about twice as large as the rate of melting of Greenland. And this is, we can see that because that as this ice shelf melts, it's putting fresh water around Antarctica. And we can actually measure the change in sea level around Antarctica. And the fresh water is lighter. So the same mass is thicker. And that causes the sea level to be higher, closer to Antarctica. And we can measure that and quantify how much melting is going on. And that's really the dangerous place because we can get several meters of sea level from West Antarctica and East Antarctica. In fact, if we look at the history of the Earth, we know that the last time the planet was, we thought, 2 degrees Celsius warmer than pre-industrial, sea level was 6 to 8 meters higher than it is now. Actually, when we look at the ambient temperature more carefully, it was more like 1.5 degrees warmer than pre-industrial. So we really do not want 2 degrees Celsius to be a target. It's not a safe target. It would guarantee that we lose all coastal cities around the world. We can't say exactly how long it would take, but it's a very dangerous target. Yeah, we need to avoid the ice sheets disintegrating. And fortunately, the United States and China are are in line to have enormous impacts from sea level rise. Florida, essentially the whole state would be lost, and China has 300 or 400 million people living close to sea level. So, and these are the countries which have to agree that we need to stop climate change. And so they need to understand that they're going to be targets. Yeah, so just to say a few things about climate extremes. The climate fluctuates from year to year just because the weather fluctuates. And so a given summer temperature at any place on land could be the chances of having a given temperature in any summer in the last half of the last century could be described by this bell curve on the left. Some summers are unusually warm, the red areas, and some are cooler than normal or cooler than average. But that bell curve is now shifting because of average global warming. It's shifting toward higher temperatures. And in the summer, when the natural variability is relatively small, that shift is enough that anyone paying attention to the climate over several years will notice that the chances of an unusually warm summer have increased. And the extreme events on the extreme right have become, instead of a very infrequent possibility, have become a significant possibility. And that, of course, so here are the last four. Well, this is actually the last 4 years, averaged over the whole year. And the temperature, the regions that are warmer than what was normal last century are yellow and brown and red. And you can see that most land areas, in most cases, are warmer than what used to be the average. The United States happens to, the last 2 years, this year and last year, have been relatively cool. It's the only place on the planet this year that's below the old average. But that's not going to stay that way. There's no reason that the United States gets the blue area. In fact, 2012 was the warmest year in history of instrumental records in the United States. And we had a huge drought throughout the Midwest. So these extreme events, with the tail of the distribution on the right, those events now happen more frequently. And when you have those places where the temperature is under one of these red areas, that tends to be where you have high pressure dominating that summer, and those areas will tend to have drought and extreme fires that go with that if you have the fuel for the fire. And we see that frequency of these fires is increasing. But at the same time, as the atmosphere gets warmer, it holds more water vapor. Because evaporation increases with the higher temperature, and that water that goes up has to come down someplace. Well, where it does come down is in more extreme events. So the 100-year flood now occurs more often than once every century. And water vapor is also the fuel for thunderstorms, tornadoes, tropical storms. So there's the potential for stronger storms as the planet gets warmer. This Superstorm Sandy was actually a relatively weak hurricane, but because the Atlantic Ocean was a few degrees warmer than normal along the East Coast, it was able to remain a hurricane all the way up to New York City, and caused, then it combined with a frontal storm and moved inland all the way to the Great Lakes, and caused a lot of damage on the East Coast, and New York City area included, New Jersey, which did finally get some attention from the politicians, although still limited attention. So now back to this question of the interrelationships. I would say I'm not an expert on human health, but let me just say a few things about it, because one interesting point is that today the hottest places on the planet, are also dry. The deserts, Sahara Desert, and the wet bulb temperature has a distribution shown by the red curve on the left, the top left, and the highest wet bulb temperature is around 30 degrees or so. If we cause global warming of, the bottom case shows if you had global warming of 12 degrees. So the point of this chart by Sherwood and Huber is to look at what's the impact if we go, instead of talking always about what's going to happen later this century, let's look 2 or 3 centuries downstream, because the world is actually acting as if it's going to burn all the fossil fuels. If we did that, we would get warming, of the order of 10 degrees Celsius or more. So they look at this at such a case. So this is not going to happen this century, but it will happen on the time scale of a few centuries if we really burn most of the fossil fuels, which is the path we're on. Well, 12 degrees increase in global temperature would be about a 8 or 9 degree increase in the wet bulb temperature, which would move a significant part of the planet to have a wet bulb temperature over 35 degrees Celsius. The human body cannot live if the wet bulb temperature is over 35 degrees. Your body can't, even if you're naked and lying in a hurricane, your body cannot cool fast enough to get rid of the approximate 100 watts of energy that your body generates. So it's a physiological and physical fact that you would die if you were in such a place. Well, the southeast United States, the center of South America, a large part of Africa, a large part of India, Australia, would all have wet bulb temperatures over 35 degrees. So the only way you could be there is if you were in an air-conditioned place. If you go outdoors, you wouldn't be able to live there you could run out and run back in. But if if you lost your power for your air conditioning, you could kiss your fanny goodbye because you can't live. And that, so it's, I mean, so it's crazy. We can't burn all the fossil fuels. It's absolutely nuts to be on such a path. That, you know, the mosquitoes that cause dengue fever are the warming is already having an impact as it causes these disease vectors to expand their range. So in the tropics, these mosquitoes can now go to higher altitudes, and the latitude range is expanding. And it's not yet a big deal in the United States, but there is an expansion of the area of this mosquito that carries the West Nile virus. And in the East Coast, this small black tick that causes Lyme disease, the range is expanding in Vermont northward, and New Hampshire and Maine and New York northward, because as the planet gets warmer, it's able to survive in an increasing range. Valley fever in the southwest United States has increased by more than a factor of 10 because of this expansion of the range of this fungus that causes it. And then some people in Minnesota who went swimming in a lake and ended up dying from something they found out, oh, this is this brain-eating amoeba, which could never live in Minnesota lakes until the Minnesota lakes started getting warmer. Okay, the number of people affected by this is still small, but if this temperature keeps going up, this sort of thing is going to be expanding into the latitudes of the United States. We're going to have more health problems related to that. So, what is clear is that we can't burn all the fossil fuels. We've only burned a small fraction. That's the purple part of the conventional oil, gas, and coal. We're going to have to leave most of the rest of this in the ground if we want to leave young people a habitable and with a remarkable planet that we've enjoyed, that the older people have been able to enjoy. But that message has not sunk in to the political system. What that means is if you look at what the climate change is caused not by the current emissions on the top, but by the cumulative emissions. The carbon stays in the systems for millennia before it's eventually taken up by the weathering process and deposited on the ocean floor. It mixes between the ocean, into the ocean and biosphere when we put it into the atmosphere, but a proportion of it remains in the atmosphere for many millennia. And the U.S. and the United Kingdom and Germany have burned far more than developing countries like China and India on a per capita basis. Unfortunately, we can't, if China and India burn as much as we did, then everybody's sunk. So we burned China's share of the allowable carbon budget and India's share. Now, we actually have an obligation to help them find an energy path that does not screw everybody on the planet. But we're not acting that way. We're acting as if it's their problem. Well, it's their problem, but it's our problem too, and we caused it. So we should be figuring this out together and cooperating. And it means, China is now the big emitter, and the coal is the biggest problem now. We're going to have to phase out coal, but we're also going to have to figure out how we can power our vehicles without using oil. We're going to have to find fuels that And we also cannot replace those with gas. There's enough gas to completely replace oil. There's these methane hydrates on the continental shelves, and both Japan and the U.S. are figuring out how to get those and use that methane hydrates. There's more there than there is in coal. So we actually have to figure out. This is United States energy consumption by source, but it's a pretty good indication of the global story, where we used coal to increase our wealth level and improve life in the United States. And then we discovered oil, gas, and they became big sources, contributors to our energy source. But unfortunately, we're going to have to phase those out and replace them with those fuels that do not contribute carbon to the atmosphere, and that's nuclear power and renewable energies. Renewable energies now contribute about the non-hydro renewables contribute about 3% of total energy. Globally, it's a fairly similar story, although coal is growing globally. But the non-hydro renewables are about 3%. And the total fossil fuel emissions is actually is accelerating. Rather than getting on this downward path, which we talked about yesterday, and which is essential to solve the problem, it's actually accelerating. And the growth in 1 year is about 3%, the last 15 years. Well, for 30 years we've been subsidizing very heavily renewables. They now contribute 1 year's growth of the fossil fuels. So you have to understand the magnitude of the problem. We have to decarbonize the energy sources, and there's only one country. There's one country that has succeeded in decarbonizing their electricity. That, as we heard yesterday, that's the fundamental requirement. We've got to get electricity is a clean energy carrier. We can clean up health problems, but we have to have electricity which is carbon-free. The only significant country that has done that is Sweden. They have hydropower and they have nuclear power. And that's the total electricity. That puts them in a position to completely solve it. They've still got 25%. They're the bottom curve there because they drive vehicles that are powered by oil. But you can make liquid fuels. If you have energy, if you have electricity, abundant electricity, you can easily make liquid fuels. And so Sweden's in a position to go zero carbon. We've got to get the world in that position that Sweden is in, and we can solve the problem. And one other thing about human health. There was this natural experiment in China when in 1950, for several decades, the Chinese government gave free coal to everybody north of this river. So the North China people got free coal for winter heating. And then there are 500 million people above and below that line. So they had a natural experiment. What is the effect of that coal on human health? And there's a paper published last year which did the analysis, and the life expectancy was reduced 5.5 years by the use of this coal. Much of it indoor use, so it causes indoor air pollution as well as outdoor air pollution. But that's only part. It's not that there was zero health effect in the South. This is just a delta between the North and the South. There's been a study by the Global Health Organization, I forget the name, published just recently, which concluded that outdoor air pollution, mostly from fossil fuel use, is killing 3.7 million people per year. And indoor air pollution, which is due to coal use, wood burning, burning of cow dung, whatever is used for indoor fuels for cooking and heating, is killing 4.3 million people per year. So if you just, and that, interestingly, about half of that is from the things you might think of, from the effect of that on your lungs. But the other half is on your heart, because these small submicron particles produced by burning fossil fuels and other fuels enter your bloodstream. And cause cardiac problems, as well as lung problems. And so one point that my colleague and I have made, Pushkar Karviche, is that the nuclear power has actually saved a huge number of lives by displacing fossil fuels as an energy source. But somehow, and if it's completely irrational in my opinion, if you look at the particles coming off from that combustion and compare that to the particles that come off from nuclear radiation, it's the black soot and the organic particles that come off from the fossil fuel burning are really, you look at them in a microscope, they're really ugly things, and they're getting into your bloodstream. How can people allow this and not be upset by that? But if we had a nuclear accident that killed 10,000 people, you would close every nuclear plant in the country. We had a nuclear accident in the United States, 3 Mile Island. If you believe the linear no-threshold hypothesis, then 1 or 2 people in Pennsylvania who were exposed to this radiation would die over the next several decades from cancer from this radiation. The same population, 40,000 people, would die from cancer from other causes. But yet that's enough to cause this kind of reaction that we saw in this thing in New York City. And it's a long story which I don't have time for here. But what I want to point out is what old geezers are planning for young people. And you need to be aware of this, because these decisions, like when Bill Clinton said, we're going to eliminate programs in unnecessary programs like research and development in nuclear power. That's a decision which has a huge impact on your future. Argonne National Laboratory was ready to make a commercial scale 4th generation nuclear power reactor, which can burn more than 99% of the energy in the nuclear fuel. Right now, the light water reactors burn 0.6% of the energy in nuclear fuel. And they leave a waste pile with half-life of more than 10,000 years. They have to babysit this waste pile forever. It's not a technology that you want to continue. So what you'd like is a technology which can burn that fuel and get the other 99% of the energy which is still there. Well, we know how to do that. And so that's what worried the environmentalists. They thought, oh, now we're going to have nuclear power forever if we let that get started. So they wanted to terminate it. And they got Bill Clinton to, it was convenient politically to agree with the environmentalists who were anti-nuclear. But we can make much safer nuclear reactors which will shut down if there's an earthquake or an anomaly. And we can make them have external, they don't require external power in order to keep the fuel cool if there's an accident. You know, it's like airplanes. If Who would have thought 3/4 of a century ago that those airplanes, we were going to allow these big boxes to fly at altitudes of 10 kilometers, and if the window breaks, everybody's done, because you can't breathe at that altitude, and and you're not going to have parachutes either. You're going to fly on those things. Well, there were airplane accidents that caused problems, but then we figure out, well, how do we make the technology so safe that it's actually safer? So now if you want to go from New York to San Francisco, you're safer flying than if you drive your car. A lot safer. You can never say the probability is zero. That's what they're requiring of nuclear. Zero probability of any accident like 3 Mile Island. Well, it's not very rational. And this nuclear fuel that we conceal from the ocean is enough to last billions of years. So it really needs to be part of the solution. It needs to be at least allowed to compete. You shouldn't eliminate it before you start. We're going to have to phase out coal, not use the unconventional fossil fuels, not pursue the last drop of oil. What's really happening? Politicians are allowing and encouraging the development of all the fossil fuels that can be found. And that's an intergenerational injustice matter, which is funny because our ideas in the United States from our very founding were that we have obligations to young people and future generations, and so do indigenous people and religions. But our governments, they don't provide leadership. They're strongly under the influence of the fossil fuel industry. So the problem is that fossil fuels are allowed to appear to be the cheapest energy. We subsidize them. We don't make them pay for their impacts on human health and climate. So what we need to do is add a gradually rising fee to the price of fossil fuels. And in order for the public to allow this, we're going to have to make it revenue neutral by giving the money to the public. And that way the person who does better than average, you give an equal amount to all legal residents of the country. The person who does better than average will actually make money. And that's a transparent, market-based approach which will stimulate innovation, energy efficiency, renewable energies, nuclear power. Everything should be allowed to compete. And that would stimulate the economy. In fact, there's been a study now, commissioned by Citizens Climate Lobby, in which they found that this gradually rising fee on carbon would, after 10 years, reduce U.S. emissions 33%, after 20 years, 52%, and it would create 3 million new jobs, and the GNP would go up. So there's no drag on the economy at all. There's no cost. It actually moves us to a better situation. And finally, it's the only way that you can get an international agreement. When we go to Paris next year, it cannot be, we can't follow the Kyoto-like approach. We have to, what is needed is not a cap. You can't get 180 countries to agree to have caps which would decline so rapidly that we could solve the problem, because why should China and India accept such a cap? Because we've burned far more than they have. They're going to demand that their caps be high. Well, what it's this we're going to have to do is have a rising fee on carbon, and then China and India will actually be better off, because it's going to spur them to move rapidly to clean energies and solve their air pollution problems at the same time it solves the climate problem. And that will also have to, and so that's the main thing, to have a carbon fee which the major countries have to agree. It's really the G2, it's China and the US that have to agree to this. The other countries will, most of them will be forced to go along, because the US and China would put a border duty on products from countries that don't have a carbon fee. that would encourage everybody to have a carbon fee, so that they can collect the money themselves rather than have us collect it at the borders. But there is an issue of fairness, of global fairness, and fortunately, we require the cooperation of the developing countries, because we're going to find out that, oh, we've got to actually suck some of that CO2 out of the air, and we're going to have to reduce these non-CO2 forcings, which are in large part coming from low-latitude countries, from developing countries. So we're going to have to help them, and that's going to require assistance, financial assistance. And so but that needs to be kept separate from this. You should not mix these up the way they did in Kyoto. That was a fatal flaw. This cap and trade with offsets, mixing up these things, did not reduce emissions at all. We've got to separate the issue of the carbon budget from the developing country assistance.